So in this problem, you're given this information: 48-degree angle, 27 degrees is the side opposite. You're given that side B has length 30. I don't know why I didn't write that in ahead of time, but anyway, that's length 30. So you're 27 and 30, and they want you to find angle B, angle C, and side little c, so that there's an obtuse angle in here somewhere. So you set up the law of sines, right? Because you've got the 27 over the sine of 48 degrees equals B over the sine of, which is 30 over the sine of B. Come on now. And you can solve for the sine of B by multiplying it up there. Anyway, you get that the sine of B is 30 times the sine of 48 degrees over 27, which is what? 0.8257, whatever. And then, so B, you do the sine inverse of that, right? 0.8257. And it turns out to be about 55.66 degrees, which, Jennifer, when you asked this question, I mean, you got that far. You then said, okay, I know the 48, I know the 55.6. You calculated angle C, and angle C was not obtuse, right? Angle C turned out to be 76 degrees or so. The thing is, there's another answer to this problem, because this is the ambiguous case. This is the angle side-side case, or side-side angle, however you want to say that. The thing is, there's two pictures. There's a picture that looks like that. There's a picture that looks... I left the B essentially over here at the same length, but this side maybe comes down this way, so it's a 27 like that. The other way we had it was the 27 over here, so maybe this is angle B right there, and this is angle A, still with its 30 here, and C's up above. So we calculated this angle right here is 55.66, which is this angle right here is 55.66, which if you look at this triangle right here, that's an isosceles triangle with these two sides being the same, so this angle here should be the same as that angle down there. So that's a 55.6. So this angle in here is 180 degrees minus the 55.66. And that's where you get that obtuse angle. So 100, let's turn my calculator on real quick, 180 minus the 55.66 is 124.34. Then you can get angle C up here, because angle C is going to be 180 minus angle A, which is 48, minus angle B, which is 124.34. So 180 minus 48 minus the previous answer, and I get an angle of just 7.66. Okay, so when you have this information, actually whenever you're using the law of sines to find an angle, you're in the situation where you might have two solutions. Right? Now, if this 27 had been bigger than 30, then it turns out you don't have two solutions, because if 27 was bigger than 30, when you try to swing this angle over to here, swing this side over there to hit this other place, well, if it's longer than 30, then it's not going to hit till it's clear back over there, and you don't get a second answer. But if the 27 is less than 30, which it is in this case, then you have this possibility of two solutions. So yeah, that's where the difference is. Of course, once you have angle C now, once you have this angle C of 7.6, you can find little side length C there, because C divided by the sine of 7.66 should be equal to, what's my original, 27 over the sine of 48. So C is equal to 27 sine of 7.66 divided by the sine of 48 degrees. The ambiguous case, when you have information about the triangle and you're using the law of sines to find an angle. Anytime you do this, the thing is there's a couple different angles whose sine is equal to 0.8257. One of them is 55.66. The other one is 124.34. So, anyway, there's that one.